Hey, Math 098, we're jumping right back into Chapter 9, Section 7 with now the common log, natural logs, and the change of base formula. And again, these are good to know when we get to calculus. If you plan on taking future math classes, this change of base formula is very, very useful. For classes like ours, though, if you have a graphing calculator, you can do any log base. This is for older calculators, or maybe your scientific calculator, maybe the calculator on your phone. It might only have the log button. Well, if I hit the log button, notice that they don't put a base in here for you. But the implied base is 10. So that's what I have written right here. If you just see log of some number, that's the same thing as log base 10 of that number. So what that means is, let's say I asked you to find log of 100, something like that. Well, then that's saying that you have log base 10 of 100, and I hope you would all be able to figure out that 10 to the second power is what gives you 100. So if I were to go to my calculator and just type in log of 100, you could close the parenthesis or you don't have to. It tells me the answer is 2. Why? Because 10 squared equals 100. So moving on to the next log, it's ln. It stands for the natural log, and it's for a base of e. Now you might not be aware of this, so I'll give you a quick mini lesson. That e, let me talk about pi real quick. That pi is always the same number. It's the same thing with e. If I hit the division sign, and then enter, you can see that number is always 2.718. If anybody's curious, I can explain where this number comes from. But we have natural log, we have the natural log key, and if you hit the natural log key, it automatically makes it into an exponent, because we use e to a power very often. So for instance, some rules that we've learned long ago is that anything to the 0 power is equal to 1. I could hit enter on that. If I do sec e to the first power, I should get the same answer as 2.718, because e is always 2.718. There's a longer explanation on where e comes from and why we use it, but for right now, let's just leave it like that. So if you ever see a problem that says natural log of e, well, because they are inverses of each other, that's the implied base, we learned, I'll even pull up the fact that we learned in the previous lesson. I think it was 2 lessons ago. Here we go. If the base if the bases are the same, they'll cancel out and they'll be equal to whatever the exponent is. So in this case, natural log of e, whoops, it was on my calculator. They cancel each other out and you're left with whatever the exponent is, which in this case is 1. So just to give you one more problem to kind of think about is if you had natural log of e to the 3rd power, natural log of e would cancel and your answer would be 3. That's the next one. And if you're curious why it's natural log and then here it's ln, is remember English is not the only language that does math. So if you're thinking of like a German-speaking person, they probably say logarithmic natural or something like that. And then this last one, again, it's important for calculus, if you plan on taking calculus, to change any log base of some number to be split up into 2 separate logs. Now, I'm well aware that your calculator, if you have a graphing calculator, will do this. If you have a scientific calculator, though, you might want to practice one of these things, where you change it to log of the of number divided by log of the base. But the one that's used in calculus more often is the natural log of x divided by natural log of b. And I'm well aware that your calculator will do log base b. So for instance, let's say I'm just making up a problem. Let's do log base 2 of 8. You should already know that it's 2 to the third power gives you 8. Okay? But what you could do is you can actually make a fraction and do natural log of 8, the of number, divided by natural log of the base 2. And when I hit the enter, I get the same answer. And this works for any log base. So if you have a calculator that does not do log base whatever, then you can do this. Let me do this slightly different. Some calculators you also might need to put in parentheses, log of 8 divided by, and I'm really overdoing the parentheses, but I don't know how your calculator works. You might have to type it in like that instead of the way I typed it in. So keep that in the back of your mind as we do some of these problems. So the first example wants you to use a calculator. And remember, the implied base is 10 for this problem. Well, we can just use a calculator, hit the button, log of 15, hit enter, and we get 1.1761. There you go. 4 decimal places. That's not very often I ask for 4 decimal places. But all you need to do is figure out how to use your calculator. As we look at the next one, find the exact value of each log. Well, remember the implied base is 10, if it's log base 10. So 10 to what power would give me 10? And that answer is 1. Now, just so for the record, I will never take away your calculator when I ask you to do these problems. So you could use a calculator and I would not be any wiser. But I think you can all figure out how to do this. 10 to what power would give me 1,000? Should be the third. Okay. And yeah, check your work. Is it true that 10 to the third power is equal to 1,000? Yeah. Yes, you could just type in log of 1,000. I'm well aware that you could just do that. But I want you to think a little bit. So as we look at the next one, what I would probably do is think about how to make a fraction. There's a fraction in there. Log base 10 of 1/10. My first gut is telling me that I need a negative exponent to make a fraction, and 10 to the first power would give me 10. And then the last one, because we've talked about this at great length, I hope it's like second nature for you, that to write a square root function is to the 1/2 power. Okay? And again, you can check your work by using the calculator. Okay? I will never give you a non-calculator test. So in the next problem, you should be able to get an exact answer. Okay, so an exact answer is without a calculator. So that can show up on a future test. And approximating is with your calculator. So remember, this is implied to be log base 10 of x to equal 3.4. So the exact answer would be changing to exponential form, that 10 to the 3.4 power would give me x. Remember our boot method we talked about? 10 to the 3.4 power would give me x. So put a box around that. That's an answer I want to see. Or the approximate answer of 10 to the 3.4 power. And rounding to 3 decimals, 2511.886. Oh, 4 decimals again. 0.8864. And if any of you are struggling with rounding, please let me know, and I can create a mini lesson for you. So don't be scared with this word problem. You may see a problem like this, but here's your equation. Put a box around that equation, and you just have to figure out what you're looking for. So this is a Richter scale that measures earthquakes. The amplitude, that's the A in the problem, is 450. So we're looking at log of 450. 4.2 is a time. That's what T stands for. I guess I should mark that. That time is right there. And then plus the b value, that's the waves, is 3.6. And that's all you need to do. And go to your calculator to the nearest tenth now. Just follow the directions with the rounding. So log of 450 divided by 4.2 plus 3.6. And so on the Richter scale, we get about 5.6. And I could talk for a while about the Richter scale, but you probably just want me to move on to the next part of the lesson. So again, they're just getting you to recognize where these buttons are in your calculator. So yeah, we're just going to find natural log right here of 13. Hit enter, and we get 2.5649. 2.5649. And by the way, this answer should make sense, because if you do e to that power, 2.5649, you get an answer that's pretty close to 13. But because I rounded it, it's off just a little bit. So that's how you can double check that you're typing this into your calculator correctly. Now we can also get the exact value of these. And I've kind of given you a few of these answers because I've already mentioned that if the bases are the same, it's an implied base of E. This is kind of written wrong, but I'm going to leave it this way. Is natural log and E cancel each other out, and whatever the power is your answer. So this answer is 4. I've had students that struggle with this. So sometimes what I do is I'll remind them that you can bring the power in front. So it's 4 times natural log of E. And as we've already discussed, natural log of E is equal to 1. So 4 times 1 would give you 4. And the same thing goes with the next one. It might be helpful for some of you to rewrite the cube root as to the 1/3 power, so you can bring that 1/3 in front. By the way, I think this is extra work. 1/3 times natural log of E. Natural log of E is equal to 1, so 1/3 times 1 is 1/3. Again, feel free to use your calculator to check your work. And as I look at the next exercise, we're doing an exact solution as well as approximating. Well, an exact answer would be changing it from the log form to exponential form, so e to the 8th power is equal to 5x. Well, if I'm trying to solve for x, to me it makes perfect sense to divide by 5. So our answer, maybe I need to explain a little bit more, that you take it to the power is equal to 5x, and then you have to divide by 5. So this would be your exact answer, and your approximate would be using a calculator. E to the 8th divided by 5. So 596.192. Well, 4 decimals again. 4916. Alright, this might be a good place to stop my video. Actually, I'm going to try and finish this. When you see compounded continuously, we use what's called the Pert Formula. It's called the Pert Formula because it looks like this. P-E to the RT power. If it helps, you can put an A in front. It's just like the compound interest problem. So P stands for principal. E is always the same number, that 2.718. Change your rate to a decimal over 4 years. And then you go to your calculator. 2,400 times E. And you might need to put in parentheses, 0.06 times 4 power. Figure out your calculator. So we're talking about 3,050. Let's just round that up to 3,051. And 0 cents. And then you have a couple options on doing this. If you figure out your calculator, you might have to type it in this way.